In this recording, we're going to go over running a single sample t-test using SPSS. So this is one of our previous labs here. This was the height, weight, sex one. And again, we coded the variables with one being for male and two being for female. So I know this was a couple labs ago, but again, the scales of measurement for both height and weight were scale, and then of course gender would always be nominal. And we already entered in the data. So the first part of the lab, what we're going to do is we're just going to run a single sample t-test. And again, the single sample t-test compares the mean of a single sample to a known population mean. Okay, so in this case, we're going to use our known population mean of 67, right? So again, this is just a sample, it's just 16 people. Obviously, there's more than 16 people in the world. We're just grabbing this small group, and we're going to give like the assumed or known population average of 67 inches. Okay, so for this one, to run a single sample t-test, you just go up here to Analyze, and then go down to Compare Means. And we're not running independent yet, we're just running one sample or single sample t-test. And let's see here. So once we do that, we just click on, sorry, my height should be over here. It should look like this for you guys. So height, weight, sex, I want to do height, so I can either use my little purple arrow to go over there, or I just double click it and it goes over. I think yours was defaulted to 0, so put your test value in as 67, because again, we're going to say, well, we just pulled these 16 people from our sample. We pulled it from a population with a known mean of 67 inches. And then I press OK, and my little window should pop up. So I have here, I have 16 people again in my sample. So in this first pop-up window, this output window here, it lists the sample variable and just some basic descriptive statistics. So again, a number of people in our study, what the average height was, the standard deviation. So if you want to round up, you just say, well, the average height was 67, but again, it's just a little bit less than that, so 66.9375 with a standard deviation of 3.9 or almost 4, right? The second window there in the output section contains the results of the t-test. So the computer actually just ran the t-test for us. And in the example that we're using here, we're going to say that, well, our t-value was negative 0.064. So if we take this whole group, right, our little sample, and compare it against our test value, if we know our population average was 67 inches, as a group, they had a t-score of negative 0.064, which is not very big at all, remember? And so we don't really kind of go like t significant versus t critical, or t crit versus t, our t-score, or t obtained. For this one, we're going to look at our more so like our degrees of freedom and the significance level, right? And so because what we're saying is, this is such a small difference that it's not really significantly different. It is different, right? So if our average height was 67 inches from the population we drew from, and our average height was 66.93 for our little group there, it is different, but it's not statistically significantly different, right? So what you would say is, you would say like, well, a single sample t-test that compared the mean height of the sample to a population had an average height of 67 was conducted. No significant or no statistically significant difference was found, and the way you would say it is parentheses t and then parentheses 15 for degrees of freedom equals negative 0.064 with a p-value being 0.95. And the sample mean of 66.9375 inches with a standard deviation of 3.907 was not significantly greater than the population mean. Okay, so for the first screenshot, I want you to send me this right here. So take a picture from here all the way over to here. And then I want you to close it, because then I want you to run it again, and I want you to see what happens when we pull this group from a different population. Okay, so again, we go up here to Analyze, Compare Means, one sample t-test, but now let's say we pulled up this group from an average height of 64 inches, right? So again, this is just a sample, so say we're going to pull those exact same 16 people, but for whatever reason we know that the population we're pulling that sample from is 64 inches. Watch what happens now. So now we see a t of positive point, or positive 3.008. So this definitely is significantly, statistically significantly different. So you would then say, a single sample t-test that compared the mean height of samples to a population with a value of 64 inches was conducted. A significant difference was found, and the sample mean of 66.93 was significantly greater than the population mean. Because what we're doing then again now is comparing this average height for our little group here of 66.9 against the average height of whatever kind of population we're pulling it from of 64. So in your second screenshot for this lab, I want you to take a picture of this, right? So again, this point, I'm just kind of having you follow the leader at this point, nothing new. Then what I want you to do is I want you to go through and I want you to add on 5 new statistics or 5 new people in your sample study here, right? So again, this is just dummy data. So I'm going to put in, right, so I'm going to say, well, one person was 60 inches tall and she weighed 132 pounds and she was a female, so I'm going to give her a 2. And again, if you're checking to see up here, A1, okay, male, female, okay. So, and then I'm going to say I had another person and they were 68 inches and they weighed 180 pounds and they were male, right? Okay, so 1 for male. And I want you to just keep going through and entering in data like this, right? So just entering dummy data, whatever you want to do there, and then kind of go through. We'll make someone like really tall, right? Become male. And then, so again, I want you to do 5 new ones. I think you start like with 16. So just go through and make 5 more. So I think you're going to go down to, 22. So 66, we'll go like 187, right? And that'll be male again. Okay, and then same thing again. So you go up to analyze, compare means, 1 sample t-test, set your test value. So maybe we'll go, I don't know, this is like a really tall group, right? And we're doing like high school basketball. That's the high school basketball players. That's the group, that the population I'm pulling this from. And I want to see if my little group here, at my really, really small high school in North Dakota, right, wherever I'm at, has a statistically significantly difference in height. So I'm going to go, okay, and the output shows me, yes, that my little high school group of boys and girls that are on this high school team, they are statistically significantly shorter than the population that had an average height of 70 inches or 6 foot 10. Okay, so the third screenshot I want you to send me is a picture of this, right? And then in addition to that, I want you to do just a small write-up of what your scenario was, right? So what was your population? If you're looking at gymnast, well then obviously you're going to have a much smaller population mean, right? The average, I think, gymnast is like 60 inches or 62 inches, whatever it is. Versus if you're looking at basketball players, obviously for high school basketball players, will be closer to 6 foot tall. So put in some dummy data, run it again, and some of that. So for this lab, we're actually going to have 3 different screenshots, and then a little small write-up too about like describing who your population was, why you set that height at that certain inches. Okay, awesome.